Dude, well, I accidentally freaking hit my power button, dude, and it stopped recording. So, but anyway, I was just saying that I'm pretty sure this is like something that we're like all capable, that we can do. I believe in us. We can do this. Okay. But I forgot. I mean, you guys took the test, so if it was on there, then hopefully it rung a bell. If it wasn't, then maybe it's better for like not there for there not to be like a complex problem like this. Okay. So yeah, that's for dilution. So dilution, the important thing is just this C1V1, C2V2, and knowing like to keep the pairs together, and then just like solving for them. All right. Total molarity. This was another thing that we did talk about. So it's just the concentration of the ions in a solution. And like I'm pretty sure, or I think you guys had a pretty good grasp on it. So just a quick rundown, right? So the first thing you want to do is check if it's an electrolyte or a non-electrolyte. So electrolytes are soluble ionic compounds. So if they have any of these, it's an electrolyte, right? And if it doesn't have any of these, it'd be a non-electrolyte. Okay. So let's go down the electrolyte path first. So once we determine it's an electrolyte, we want to find the ratio of the ions, or the ratio of like the pieces, right? So if we look at this example, right? Na3P, right? If we look at this, there are 3 NAs and there's 1 P, right? How about this one? NH4, 2S. Well, there's 2 NH4s and there's 1 S. But be careful between this NH4 and like this 2. Like this is a polyatomic, so you kind of treat it as like you keep it together. So this isn't 2, so like you would keep it with like NH4 and just 2 of them. You wouldn't have like 2 N's, like you wouldn't apply this 2 over here and then like H8, like be careful you don't do that. So the NH4 stays together and there's 2 of them, so you have 2x NH4, 1s, and then NaCl, we have 1 Na, 1 Cl, right? Okay, so now we're going to use the ratios to find the individual ion molarities and then add, right? So if we use the same like substances, but this time we're like looking at like a concentration, all we're doing is we're multiplying the concentration of like the original thing by the ratios. So for if we wanted to find like for Na, right, we said there's 3 of them, so it would be 3 times the original concentration, right? And then for P, there's only 1, right? So 1 times 0.5, 0.5. You add them all together and you get a total molarity of this, 4.0 total molarity. Yeah, and pretty much just the same process over here as well. So we said there was 2 NH4s, right? And we're dealing with 0.1 molar. So 2 times 0.1 plus there's 1s, and the molarity was 0.1. So it's just 1 times 0.1, and then you add them together, 0.3 molar. Okay. And then NaCl, so there's 1 Na. Oh, I messed up here. I meant to put that this is a 0.1 sample. But that's where I would have got these 2. And it's just the same process. So that's how you do total molarity for an electrolyte. So that's if it splits up. So if it's soluble. If it's a non-electrolyte, meaning it's either a covalent compound or an insoluble ionic compound, whatever they give you, the molarity given is your total molarity. So if they're like 0.27 ethanol, right? This would be that would be your final answer. Like, you don't need to do any adding, any multiplying. That's just what they give you, right? I didn't put any examples on. I guess these were the examples, to be fair. I should have put it. Yeah, I should have put an example for this. That would just be like, what, 0.27. Ethanol would just lead to 0.27 ethanol. Yeah, like that would be an example of the non-electrolyte. Okay, so I think you guys got that one pretty well, though. So now we move on to, I think, the last of the core material, which is osmosis and dialysis. So what are these two words? Osmosis is the movement of water towards areas of higher total molarity, right? So if one has, so if you're like looking at these two, okay, actually, never mind. I think I should just go over the different definitions and then we'll talk about the example. So osmosis, it's water towards higher total molarity, I'm sorry. And dialysis is just the movement of ions or molecules, right? Like osmosis, water, dialysis is just like the other stuff, towards areas of lower concentration or molarity. Okay? So, now let's look at the example. Right? Here we have solution C and D. Solution C has this, solution D has this, and this. Right? First question, which direction does osmosis occur? Well, we said that it was referring to the one with higher total molarity. So let's find the higher total molarity. So in solution C, NaCl is 0.1. So that would be 0.2 plus 0.2, total 0.4. Right? So we have this non-electrolyte, so it stays 0.2. NaCl, that's Na, and then plus Cl, so that's going to be 0.1 times 2, so 0.2. So this one has a total molarity of 0.4. And this one, let's see, NaCl, Na plus Cl, so this would be 0.15 times 2. So this would be 0.3 plus the 0.1 from glucose, so this would also be 0.4. Total molarity. So, which direction does osmosis occur? No direction, because they have equal total molarity. But if it was different, and instead of being 0.4 and 0.4, if it was like 0.5 and then 0.4, osmosis would occur from solution D to solution C. If it was 0.5 and 0.4, right? Because osmosis occurs from the lower, hold up, no, that's going to be confusing. Osmosis goes towards the place of higher concentration. So 0.5 is greater than 0.4. So osmosis would occur from this direction, from solution B to solution C. If, once again, that's if this was 0.5 and 0.4. But since the values that they gave us, it was 0.4, the actual values are this, there would be no osmosis. Okay, next one. Which direction does N minus dialyze, or Cl minus dialyze? Well, Cl, we know Cl is here. There's 0.1 of Cl versus 0.15 of Cl. So there's more in this one. And we said that for dialysis, it goes towards areas of lower concentration, right? Oops, sorry. Ions and molecules towards areas of lower concentration. So, since solution C has the lower concentration, it would go from solution D to solution C. Which direction does glucose dialyze? So glucose, right? This one has 0.2, this one has 0.1. Okay? So once again, dialyze, you go towards the area of lower concentration. So this would go from C to D. Okay? So I'm not sure how you guys would like to remember that, like, personally. It's just that water for osmosis, right? Osmosis is water. And what does water do? It goes towards areas of higher total molarity. Whereas dialysis, it's ions and molecules towards areas of lower concentration or molarity. I don't think I have any ways for any like particular way that I remember that, but I'll leave it up to you guys. And then another thing to like watch out for would be here, this part of the problem where it says a membrane that is permeable to water, glucose, and ions. So I think it was a test. I forgot which, if it was, I don't know if it was an outlier or a test, but they might trick you and be like, it's a membrane that is permeable to water and ions, and it doesn't say anything about glucose. If that's the case, all permeable means is that the stuff can move like back and forth from this side or from this side. That's what permeability means. But if like a certain thing was like they didn't include, if they just said water and ions and not glucose, and they still asked this question, well, it wouldn't go anywhere because it wasn't permeable. But that's why it's just be careful. Just be careful to like certain parts of the question. Okay? That it could be a lot. There might be a lot though. So definitely just like take it easy. Or like there's no need to like I'm pretty sure this is still like a lot of information. So just take it at your own pace. I am still really sorry that like I kind of messed you guys up and I kind of got too focused on the moles, so I'm trying to repay it back, dude. So yeah. So that's for osmosis and dialysis. And then this last part, on the study guide, it said it was like extra information, but I'm pretty sure I just saw it on like STA5. But we're talking about blood tonicity, okay? Blood tonicity. So in the blood, it has like a molarity or concentration of 0.28, okay? So 0.28 is like our reference value. So there's 3 types of different like solutions for like the blood. And this is in reference to like IV fluids as well. So we have hyper, iso, and then hypotonic. If it's hypertonic, hyper high, that means whatever the solution is, the concentration or molarity of it is higher than 0.28. So hypertonic, higher than 0.28. Okay? Isotonic, it just means it's equal or the same. I don't know if there's like I can't think of anything really clever to like remember that. And then hypo is lower than 0.28. But yeah, I guess for me, the most part is just hyper. It's higher than 0.28. Hypo is kind of like low because, yeah, I don't know how it works in my head, or that's how it works in my head. I don't know if it would work the same way for you guys. So hyper is high, hypo is lower, and then that just leaves iso with being the same or equal. Okay? Now that you identified what the solution could be, they might also they probably will also ask for what will happen to the red blood cell when it's put into that like solution. So if it's hypertonic, it leads to crenation. It starts with a C, and I'm pretty sure it'll be an option on the test. So hyper, crenation, and then hypotonic would lead to hemolysis. Okay, I'm not really sure how you guys want to remember that, but yeah, that's just, it's hyper leads to crenation, hypo leads to hemolysis, isotonic doesn't do anything. So the main focus are just on these, like on hyper and hypo. Okay. So I just put like a little like quick example, right? So if a solution of 0.15 molar NaCl, so this would be hypertonic, right? So 0.15 NaCl, this is oh shoot, look at you. 0.15 what's it called? Solution. Oh, okay, dude, I got distracted. Solution of this, so NaCl, there's one Na plus one Cl. So there's two things, so 0.15 times 2, that'd be 0.30, which is 0.30, which is greater than 0.28. Hypertonic leads to crenation. Okay. Next example is 0.25 molar, right? 0.25 molar. Ethanol, so this is a non-electrolyte. So this is your final thing, 0.25, and 0.25 is less than 0.28, right? So there you're going to have hypotonic and lead to hemolysis. Oh, dude, I didn't finish it. It's supposed to be NaCl. Okay, 0.14 NaCl, there's Na, and then there's Cl. So you have to multiply the 0.14 by 2. So 0.14 times 2 equals 0.28, which is equal to blood. So it's isotonic, no effect. And that's, what's it call it, dude? That's unit 5, hopefully, I think. Actually, take your time to like take the information in, and I hope this helped. Yeah.